Buying a car in Carvana was so easy. I was able to finance it through them.
Whoa, wait, you mean finance?
Yeah, finance. Got pre-qualified for a Carvana auto loan, entered my terms, and shot from thousands of great car options, all within my budget.
That's cool that financing through Carvana was so easy.
Financed. Done. And I get to pick up my car from their Carvana vending machine tomorrow.
Financed.
Right, that's what I said.
You can spend time trying to pronounce financing, or you can actually finance and buy your car today on
Carvana.
Financing subject to credit approval. Additional terms and conditions may apply.
Buying a car in Carvana was so easy. I was able to finance it through them.
Whoa, wait, you mean finance?
Yeah, finance. Got pre-qualified for a Carvana auto loan, entered my terms, and shot from thousands of great car options, all within my budget.
That's cool that financing through Carvana was so easy.
Financed. Done. And I get to pick up my car from their Carvana vending machine tomorrow.
Financed.
Right, that's what I said.
You can spend time trying to pronounce financing, or you can actually finance and buy your car today on
Carvana.
Financing subject to credit approval. Additional terms and conditions may apply.
Hey everyone, welcome back to my podcast, Anatomy and Physiology Bit by Bit. This is your host, Dr. Steve Sullivan from Bucks County Community College, just outside of Philadelphia. I'm glad you are back with us. This is our 20th official episode, not including our 3 bonus episodes, so it's nice to hit a nice round number of 20. Trying to keep the episodes coming, and I'm glad that I've got listeners who are reaching out to me and rating the podcast, which is really nice, and giving a quick review. I've been really appreciative of all the great feedback that I've gotten. So thanks so much for continuing to download, continuing to listen, and continuing to reach out. I actually got a great email from a listener in the Netherlands, and her name is Karina. I actually have a niece named Karina. But this Karina from the Netherlands isn't even an A&P student right now. She's just listening because she's interested and maybe wants to get into medicine. And Karina asked me if there are any books that I recommend for someone like her, specifically really kind of getting in and understanding some of the biochemistry that's involved in physiology. So it's really important to have a good chemistry base when you start to study physiology. So that's why most 2-semester anatomy and physiology books will have a chemistry chapter early on, like chapter 2. So I recommend getting like a general light chemistry book, maybe a non-majors chemistry book, if you can. That could be really helpful. But something I would really recommend is getting an essential, what they call an essentials book. So here's an example. A good friend of mine named Michael Windelspecht is an author of Mater's Human Biology, and it's published by McGraw-Hill Higher Education. And it's a really good book to get yourself into a level of human biology that is going to be very helpful for you to move forward with a degree in some kind of health-related field. And it's written in a way that is eloquent and succinct and accurate and relatable in a way that Dr. Windelspecht does often. So I recommend that book. I think that would be a really good start to get yourself in there if you're not quite taking the class yet. So when you take the class, you'll probably have a book assigned by your professor, and that'll probably be a 2-semester anatomy and physiology book, which would be more like a majors level textbook. Another one of those books is called Hull's Essentials of Anatomy and Physiology, and it's written by Dr. Chuck Welsh, who teaches A&P at a college in Pennsylvania. So that's another one that you could get your hands on. It is a textbook. So again, these are a little bit on the more expensive side. But if you're looking just to brush up, don't forget about my website that I linked to in the episode description. And that website is a&ponlinematerials.weebly.com. And on that website, you will find access to well over 100 tutor videos that I've created, including lab videos and lab materials that I use online for my students, especially during pandemic. So any of those I think will be good resources for you. the Mater's Human Biology by Dr. Michael Windelspecht, the Hole's Essentials of Human Anatomy and Physiology by Dr. Chuck Welsh, and my website, anponlinematerials.weebly.com. I think all of those will help you to learn and understand as much as you possibly can as you're moving forward. So good luck, Karina. Thanks for reaching out. I really do appreciate it. I think we can probably move on now and maybe talk about reflex arcs and reflexes and spinal nerves and all that good stuff. The nervous system is not going away anytime soon. We are going to keep tackling this thing as we move forward. So let's get on it. In the last episode, we talked about spinal nerves and how spinal nerves emerge from the spinal cord. And they do that in different regions of the spinal cord. Remember, there was the dorsal side of the spinal cord in cross-section and the ventral side. And the dorsal side is the area where nerve signals from the periphery of our body, sensory nerve signals, come into the spinal cord. And the ventral part of the spinal cord is where motor signals go out. So attached to the dorsal side of the spinal cord are nerve fibers called rootlets, dorsal rootlets. And those rootlets are, nerve fibers that are separate, that are going into that spinal cord in that area. And then not far off from those rootlets are the dorsal roots. So those rootlets all converge together to form like a more dense cord-like material, and that we call the dorsal root. And inside that dorsal root is a dilation, a swelling, where the nerve cell bodies are found for sensory neurons. So the cell bodies of neurons are in this dilation, and we call that dilation the dorsal root ganglion. So you don't see that on the ventral side because the cell bodies for the motor neurons are not located there. So on the dorsal side, we have separate rootlets. They converge into a dorsal root. On the ventral side, we have ventral rootlets. And those ventral rootlets, they converge into a ventral root, no ganglion. And then the ventral root and the dorsal root actually converge into one another. Now, the dorsal root only has sensory nerve fibers in it. So only sensory neurons are in that dorsal root. Only motor neurons are in the ventral root. So keep that in mind. That's really important. When the ventral root and the dorsal root come together, that's when we have a spinal nerve. And the spinal nerve has both motor and sensory neurons in it. It's a mixed nerve. And then that spinal nerve is what exits the vertebral canal through that intervertebral foramen. Now, once that comes out, it's going to start branching off. So the spinal nerve will have branches coming off of it that are going to distribute themselves to the areas of the body they innervate. Those branches are called rami, which are plural, rami is plural for ramus. So there's a dorsal ramus. The dorsal ramus is going to go posteriorly and innervate the deep muscles and the skin of the posterior surface of the trunk of your body. There's also a ventral ramus. The ventral rami, they innervate the muscles of the upper and lower limbs and the skin of the anterior and lateral surfaces of the trunk. So the ventral rami, those are the ones that are going to go out and become all the named nerves that we know about. We hear about the radial nerve and the ulnar nerve and the femoral nerve. Those are all extensions of ventral rami. Even the nerves that travel between your ribs, we call the intercostal nerves, they are extensions of ventral rami. Now, we also have some much smaller branches, like the meningeal branch, which backtracks and re-enters the intervertebral foramen and innervates the vertebrae, the vertebral ligaments, the blood vessels of the spinal cord, and the meninges, the 3-layer covering we talked about in the last episode. And then another branch we have is really 2 little branches called the rami communicantes, or the communicating rami. And they innervate the components of the autonomic nervous system, which is our visceral reflex integrating center. So our fight or flight, or rest and digest portions of our nervous system. So that's the distribution of spinal nerves. Now, what the ventral rami then do is in the cervical region of your neck and your upper back, and in your lumbar and sacral region, ventral rami come from those enlargements in the spinal cord, the cervical enlargement, the lumbar enlargement. Ventral rami coming from those areas, not only do they start to distribute themselves toward parts of your body, but those ventral rami, they have branches that then join up with branches of adjacent central rami and form this kind of cargo net mesh network of nerves called a plexus. And then the named nerves, the nerves we know about that go off and then specifically innervate parts of your upper limbs and lower limbs and shoulders and hips, those come out of those plexuses. There are 4 plexuses and they're bilateral. There's a cervical plexus, there's a brachial plexus, there's a lumbar plexus, and there's a sacral plexus. And that's in order from top to bottom. The cervical plexus comes from the ventral rami of the C1 to... On the ventral side, and the major functions of the cervical plexus is it innervates the skin and the muscles of the head, the neck, the superior part of your shoulders and chest. It provides motor innervation to the diaphragm via the phrenic nerve, so that way your diaphragm can contract so you can breathe. So that actually, even though your diaphragm is the floor of your thoracic cavity and the roof of your abdominal cavity, it's innervated by a nerve that comes all the way out of the cervical plexus and travels down the thoracic cavity to that area. It's called the phrenic nerve. This is why cervical spine injuries just below C5 don't require a ventilator for the patient, because they still have control of that phrenic nerve. You're also going to see innervation to the deep muscles of the neck, like the levator scapulae and the middle scalene muscles. Those are all innervated from nerves that come out of the cervical plexus. The brachial plexus, that's the one that's going to go and innervate most of your shoulders and your upper limbs. And the nerves we see coming out of there are like the axillary nerve, which innervates your deltoid muscles and your teres muscles, the musculocutaneous nerve for the biceps brachii and brachialis muscles, the radial nerve, that's your triceps brachii, and a lot of your forearm extensors, the median nerve, which is the one that gets injured when you have carpal tunnel syndrome. That's like most of your forearm flexors from this median nerve that runs down the midline of your forearm. And the ulnar nerve, that's the nerve that causes the funny bone sensation when you bang your elbow, because that medial epicondyle of your elbow has a little groove that the ulnar nerve goes in, and then the ulnar nerve really only has a little bit of skin and fat covering it. So there's not a whole lot of protection. If you bang that against something, you get this like shock-like pain and numbness and tingling, what we call dysesthesia, shooting down the medial part of your forearm and hand. And that's the ulnar nerve. So those all come from the brachial plexus. And the brachial plexus is formed from the ventral rami of C5, 6, 7, 8, and T1 spinal nerves. So now I said C8, but we only have 7 cervical vertebrae. So now we got a little bit of a weird spot, right? I said that the nerves are named for the vertebral segments from which they emerge. However, C1 nerve, the C1 nerve comes out above the C1 vertebra, superior to it. So that means between the occipital bone and the first cervical vertebra is where the C1 nerve comes out. So that means C2 nerve comes out below C1 or above C2. C3 nerve above C3 vertebra, and so on. After the C7 vertebra, the next nerve is actually still a cervical nerve, and we call that the C8 spinal nerve, or the 8th cervical spinal nerve. Then we start with the thoracic nerve. So the T1 nerve comes out after that below the T1 vertebra. So we have 8 cervical spinal nerves. C5 through 8 plus T1 all combine to form the brachial plexus. The lumbar plexus is all the way down at the L1 to L4 ventral rami. So the ventral rami have those spinal nerves. And these nerves are going to be innervating the anterolateral abdominal wall, the external genitals, and parts of the lower limbs. We'll see the femoral nerve coming out of this one, the obturator nerves, which is for the adductors of the hip, but the femoral nerve. And then the last plexus that we're going to talk about is the sacral plexus. And the sacral plexus is made up from the ventral rami of the L4 and 5 spinal nerves, as well as those of the S1, 2, 3, and 4 spinal nerves. And those nerves coming from the sacral plexus are going to innervate the gluteal region, the perineum, and the lower limbs. In fact, the sciatic nerve, which you've probably heard of, which innervates the hamstrings and the adductor magnus, is going to come from it, as well as the tibial nerve, which is what's going to innervate the gastrocnemius, the soleus, the plantaris, popliteus, a lot of your calf muscles. So the motor and sensory innervation is coming from those plexuses, and it's a pretty big thing to remember. So that pretty much wraps up spinal nerves and spinal plexuses.
Bombas makes the most comfortable socks, underwear, and T-shirts.
Warning, Bombas are so absurdly comfortable you may throw out all your other clothes.
Sorry, do we legally have to say that?
No, this is just how I talk, and I really love my Bombas.
They do feel that good. And they do good, too. One item purchased equals one item donated.
To feel good and do good, go to Bombas.com and use code AUDIO for 20% off your first purchase. That's BOMBAS.com and use code AUDIO at checkout.
Hi, I'm Kristen Bell, and if you know my husband Dax, then you also know he loves shopping for a car. Selling a car? Not so much.
We're really doing this, huh?
Thankfully, Carvana makes it easy. Answer a few questions, put in your VIN or license, and done. We sold ours in minutes this morning, and they'll come pick it up and pay us this afternoon.
Bye-bye, truckie.
Of course, we kept the favorite.
Hello, other truckie.
Sell your car with Carvana today. Terms and conditions apply.
I'd also like to talk about reflexes. So I think this is a good time to discuss what a reflex arc is. So reflexes in general are happening all the time, and they're not just like getting your knee hit with a hammer and kicking your leg. That's not the only kind of reflex we have. Reflexes are regulating your heart rate and your respiratory rate and all kinds of other visceral functions that are happening in your body are quick, predictable responses that are beyond your voluntary control. This is what a reflex is: a quick, predictable, automatic response that's involuntary and responds to changes in the environment. So we've got all kinds of reflexes. We have cranial reflexes, which are reflexes that go to the brain and don't have to even go up the spinal cord. For example, if you shine a light in someone's eye and their pupil constricts, that's a cranial reflex. So they originate in the brain or brainstem, and they travel through the cranial nerves. That's a cranial reflex. We have autonomic reflexes, or also known as visceral reflexes, and these involve responses of smooth muscle, cardiac muscle, glands. We don't perceive these reflexes. They're responses to changes in blood pressure that cause an increase in heart rate, for example, or even food entering your stomach is going to cause a reflex in the gastrointestinal tract that makes sure it makes room in the colon for later. That's another kind of reflex. But then the reflexes we're going to focus on in this episode are somatic reflexes or spinal reflexes, and they involve the contraction of skeletal muscles that are beyond your control. And the knee-jerk reflex is one of these. The patellar reflex, hit a patellar ligament with a hammer, you cause your quadriceps muscles to contract. So all of these reflexes, whether they're autonomic or cranial or somatic, they all work on what's called a reflex arc, which means a nerve signal has to travel from the periphery of the body or from the stimulus that's causing it to the central nervous system, and then another reflex has to be generated that comes back out and stimulates a gland or a muscle to do something in response to that stimulus. That's a reflex arc, and regardless of what kind of reflex it is, they all require 5 key components. 1, something needs to respond to the change in the environment, and that means you need a receptor. So a sensory receptor is the first required component of a reflex arc. So it responds to a specific stimulus and it initiates a nerve signal if that stimulus is strong enough. Then you need a way for that nerve signal to get to the central nervous system, and for that, we require a sensory neuron. So a sensory neuron carries the nerve signal to the central nervous system. And in the central nervous system, we now need a part of your CNS, your spinal cord, brainstem, brain. We need a part to analyze the nerve signal or data that's coming in and decide on the most appropriate response. And we call that the integrating center. The integrating center is the part of the central nervous system that receives the data and decides on what the response is going to be. Once that happens, a nerve signal needs to be sent out to whatever tissue is going to carry out that response. And for that, we need to generate a motor signal and have it travel along a motor neuron. And then finally, the tissue that will carry out the response is called the effector. Whatever's going to have the desired effect or create the desired effect is called an effector. So in the knee-jerk reflex, the receptor is in the muscle of the quadriceps muscle. The patellar ligament is hit with a hammer. It causes a very quick stretch, and that triggers stretch receptors in the quadriceps muscle where the tendon meets the muscle. That generates a nerve signal in the sensory neuron. The sensory nerve signal travels into the spinal cord. A part of the spinal cord has a synapse in it, which is 2 neurons communicating with each other. You remember that from previous episodes. And then the last plexus that we're going to talk about. The integrating center then generates a motor nerve signal on a motor neuron that leaves the spinal cord through the ventral rootlets, ventral root, into the spinal nerve, etc. And that motor nerve signal travels out to the effector, which is going to be our quadriceps muscles. And when the quadriceps femoris muscles get that nerve signal, they contract, causing you to extend your knee to shorten up the muscle in response to this quick stretch that happened. The quadriceps femoris muscles in this case is the effector. So what I just described to you is the stretch reflex, which is our most basic reflex. And so let's start with that one as we get a little bit more specific. So the stretch reflex is a way for our bodies to protect us from muscles being stretched quickly and abruptly and putting them at risk for being damaged. That's the problem. So we want to have a counter action to prevent that damage from happening. So we have a contraction of the muscle to counteract the stretching of the muscle. So let's look at it one more time. And we'll be specific about the stretch reflex. And this happens in almost all of your skeletal muscles. You can do it in your biceps brachii, you can do it in your hamstrings, you can do it in your brachioradialis, you can do it in your calf muscles. You can do this in almost any skeletal muscle you can reach. You can elicit a stretch reflex. So here's what happens. Let's say you're doing the patellar reflex. Your patellar ligament is the ligament that travels from your patella to the tibial tuberosity of your tibia. And on the other side of that patella is the quadriceps tendon that attaches to the quadriceps muscle group, and that quadriceps, the integrating center, then bends your knee or straightens your leg. So when you hit it quickly with a reflex hammer, it causes a very quick stretch. And that stretch triggers mechanically gated sodium ion channels in what we call muscle spindle fibers, which are stretch receptors. They're sensory receptors in the muscle, and they have in their plasma membrane, they have mechanically gated sodium ion channels, right? So I'm bringing you way back, right? If we use that mechanical stimulus to open those ion channels, we will depolarize the membrane, cause a local potential that reaches threshold, and if it reaches threshold, it causes an action potential, which now generates a nerve signal in the sensory neuron that innervates the quadriceps femoris muscle. So now that sensory nerve signal will travel all the way to the end of that sensory neuron, which is in the spinal cord at the L4 level. So the sensory nerve signal travels back up to the spinal cord, or let's say to the vertebral canal, in the intervertebral foramen, and then as the spinal nerve splits into a dorsal and ventral root, the sensory nerve signal follows the dorsal root, passes the dorsal root ganglion, into the dorsal rootlets, and into the dorsal horn of gray matter of the spinal cord. In the gray matter, that sensory neuron synapses directly with a motor neuron. So we have a chemical synapse. A neurotransmitter is released by the presynaptic neuron, which is the sensory neuron, and that opens or stimulates the opening of ligand-gated ion channels in the motor neuron's membrane. And that will generate another local potential. And if that local potential reaches threshold, an action potential is generated, and that causes a nerve signal along the motor neuron, which then goes out the ventral horn of gray matter, ventral rootlets, ventral root, into the spinal nerve now, out the intervertebral foramen, and all along the motor neuron that innervates the quadriceps femoris group. When it gets to the quadriceps femoris group, the axon terminals of that motor neuron release acetylcholine as a neurotransmitter to the neuromuscular junction, and that results in, again, a motor end plate potential, which may or may not cause a muscle action potential. If it reaches threshold, it does, and then the muscle action potential happens, and you get muscle contraction, and the quadriceps femoris group contracts, shortening and counteracting the stretching. I know that I got really super specific there, but that's why we teach it like this in A&P. Because the reason why we spent so much time on the plasma membrane of a cell and plasma proteins and gated ion channels and chemical synapse and neurotransmitters and ligands and mechanically gated ion channels is because it matters. Because it all applies to exactly what we are talking about. So that particular reflex is the simplest one because it was a simple synapse in the spinal cord's gray matter of the sensory neuron and the motor neuron. One synapse is all that's required for this reflex arc to be complete. So we call that a monosynaptic reflex arc. Now, since it innervated the same muscle that was stimulated, it happens on the same side of your body. So that's also known as an ipsilateral reflex arc, which means on the same side. So we have a monosynaptic ipsilateral reflex arc, and that's the stretch reflex. It is the simplest of the somatic reflexes. Now, at the same time, there is an inhibitory nerve signal being stimulated in the gray matter so that the motor neuron of the hamstrings muscles, which is the antagonist of the quadriceps femoris muscles, we want those to turn off because it's much easier to shorten your quadriceps femoris group if your hamstring group isn't contracting in opposition. So we have what's called reciprocal inhibition. At the same time that we are stimulating the quadriceps muscles to contract, we are inhibiting the hamstring muscles from contracting. So it's easier to achieve our goal. So an axon terminal of the sensory neuron not only synapses with the motor neuron for the reflex arc, but another branch of it synapses with an interneuron in the spinal cord's gray matter. And that's an inhibitory interneuron. So that interneuron, which synapses with the motor neuron for the hamstring muscles, that interneuron is inhibitory, which means it will release a neurotransmitter that causes an inhibitory postsynaptic potential in that motor neuron. So now we get into the IPSPs. Remember, I said in a previous episode that that's important. It's just as important to hyperpolarize the membrane as it is to depolarize the membrane. So that's happening too. We have reciprocal innervation. We have another line of neuron that's trying to achieve the opposite that the reflex is trying to achieve. And that makes the reflex easier. So we're trying to inhibit the opposite, I should say, because it makes the reflex even easier to happen. All right, so if we have a reflex that protects the muscle from overstretching, we also have a reflex that protects it from overcontracting, because contracting a muscle too hard can also damage it. So we have another reflex called the tendon reflex. And this one does the opposite of the stretch reflex. If you've ever jumped off a table and when you land, you feel your legs give a little bit, that's an inhibitory reflex. When you land, your quadriceps femoris group are contracting really hard, and your body doesn't want that, so because it's dangerous for that muscle. So a quick reflex happens that inhibits those muscles, so that way they stop contracting for a quick second, so they don't damage themselves from overcontraction. We call that the tendon reflex. So we have what's called tendon organ sensory receptors, and these are contraction specific. They're looking for tension. And when excessive tension is created, that stimulates that receptor. It generates a nerve signal in the sensory neuron that goes up to your spinal cord, in your spinal cord, and it synapses with an interneuron that's inhibitory. And then that inhibitory interneuron creates an IPSP at the motor neuron that goes to the same muscle. So that way it turns that motor neuron off. It inhibits it. So the muscles, they weaken for a second. They turn off. Right? And that's the ultimate goal of that particular reflex. This one we have to call a polysynaptic reflex because it requires two synapses to achieve the arc. The first one is the synapse between the sensory neuron and the interneuron, and the second one is the synapse between the interneuron and the motor neuron. So now we have an ipsilateral polysynaptic reflex arc. That's the tendon reflex. Now another cool one is the flexor reflex or the withdraw reflex. The withdraw reflex is interesting because let's say you're walking and you step on a Lego, or you have bare feet and you're in your house and one of your kids left a Lego sitting on the floor and you step on it, it hurts. It stimulates nociceptors, which are the tissue damage receptors in your foot. And your response is to withdraw from that stimulus. Same thing as if you touched a hot stove and you pulled your hand back real fast, right? You have a withdraw reflex. So this one is interesting because in order to withdraw from the Lego you stepped on, you've got to flex your hips and your knee. You get your hip flexors have to engage. You pull your knee up to the sky. So you bend your knee and you pull your knee up. Hip flexors and knee flexors, they're coming from different segments of your spinal cord. So the sensory receptor that's stimulated sends a nerve signal from the bottom of your foot up into your spinal cord, and then that has to synapse with interneurons that travel up and down the spinal cord to a different segment so that they can synapse with the motor neurons that go to your hip flexors and knee flexors. And those are coming from different segments. So now we have a polysynaptic, ipsilateral, intersegmental reflex arc. Multiple synapses, same side of your body, multiple segments of the spinal cord needed. So we have a polysynaptic, intersegmental, and ipsilateral reflex arc. Sorry, I got myself confused for a second. So it's a lot to remember. And then think about it this way. You step on that Lego, you pull your foot up. You have to also shift your weight to your other leg, your other lower limb, so that you don't fall down. So you have to straighten your hip and your knee on the other side of your body to hold your weight up while you pull that other foot off the ground. That we call the crossed extensor reflex. So that nerve signal that comes into your spinal cord has terminal branches on the axon terminals that cross the midline. I'm sorry, I shouldn't say that. They have axon terminals that synapse with interneurons that cross the midline of your spinal cord, then go up to different segments and then synapse with motor neurons that go to the other lower limbs, hip extensors and knee extensors, so that you can stand up on the other leg while you pull your foot up off the ground. That's the crossed extensor reflex. Now we have a polysynaptic, intersegmental, contralateral reflex arc because it goes to the other side of your body. Right? There's a lot going on just to keep ourselves going. And those are just some examples of somatic reflexes and how that reflex arc works. So I hope that that's something that you can really kind of absorb and break down and think about. Because I know I gave you a lot. This is an episode you might want to listen to a couple of times, just to digest all that information.
Bombas makes the most comfortable socks, underwear, and T-shirts.
Warning, Bombas are so absurdly comfortable you may throw out all your other clothes.
Sorry, do we legally have to say that?
No, this is just how I talk, and I really love my Bombas.
They do feel that good. And they do good, too. One item purchased equals one item donated.
To feel good and do good, go to bombas.com and use code AUDIO for 20% off your first purchase. That's BOMBAS.com and use code AUDIO at checkout.
But I think that's plenty for today. We're definitely getting into the long end of this episode. So again, spinal nerves, reflexes, we really kind of boiled a lot down today. So I hope that this is something that's really helped you out. I hope that this is going to help you understand a little bit better and maybe even do a little better on your next test. So thanks so much for listening. Thank you again, Karina, for your email. And I will see you next time when we continue on with more nervous system. Have a good one. Hey everyone, don't forget to check out my YouTube channel, Student Help for AP. Student Help, the number 4, AP. There's a lot of tutor videos on there that I think could be really helpful. I also have an Instagram account and a Twitter feed with the same name. Anatomy and Physiology Bit by Bit is a production of Minus 55 Media, with a special thanks to Bucks County Community College, McGraw-Hill Higher Education, and my family.